Okay, in this video we are looking at sound waves. So you need to know some of the properties of sound waves. Property number 1, these waves are longitudinal waves. That just means that the direction of wave travel is parallel to the direction of the vibrations that cause these waves. Property number 2 is to do with the speed of waves. Now, unlike light waves, sound waves actually travel quicker in more dense materials. We need to think about how sound waves travel through materials to make sense of this. You may remember from the introduction to waves that sound waves are made up of compressions and rarefactions. When that sound wave is an incident on a material, such as a solid, those changes in pressure of rarefactions and compressions cause the particles in the solid to vibrate. These particles then hit their neighbours, which hit their neighbours, and so on and so forth, so that the sound wave can travel through the material. And since the particles in a solid are more closely packed than a liquid or a gas, this process is able to happen a bit quicker. So, since the speed of these waves change, and we know that speed equals frequency times wavelength, then one of those two things must change too. And it does. It is the wavelength of your sound waves that changes in different materials. So when the sound waves travel from air into a solid and the speed of the wave increases, that must mean that the wavelength also increases. The frequency of your waves stays the same. And just like light waves, sound waves are able to refract and also reflect. In fact, that's exactly what an echo is. But unlike light waves, they cannot travel through a vacuum. Remember, sound waves rely on those particles vibrating to propagate the wave. In a vacuum, there are no particles, so there are no sound waves. We can take our own little spin on that classic philosophical question. If a person screams in space and nobody hears them, did the person ever scream? I've lost the plot. Okay, now it's important to realise that actually not all frequencies of sound can be transferred through any object. It very much depends on the 3 S's: the size, the structure, and the shape of that object. And depending on your object's size, structure, and shape, only certain frequencies can be transferred through that object. This can help describe why humans can only hear frequencies between 20 and 20,000 hertz. We are very much restricted by our ears' size, shape, and structure. So how do your ears work anyway? Let's quickly run through the process. Sound waves reaching your eardrum cause it to vibrate. Those vibrations are passed through some tiny bones until they eventually reach your cochlea. The cochlea then turns those vibrations into electric signals that get sent to your brain. It's your brain's job to then interpret those signals as different frequencies or pitch and different amplitudes or loudness. Sorry. Okay, hope you found that helpful. Make sure to download the notes. Please do like and subscribe. Thank you for watching.